Welcome to a further maths video on solving differential equations. So following on from solving homogeneous differential equations, which is equations which have equals 0 on one side, we're going to go on to solving non-homogeneous differential equations. Those are going to be equations of the form like we saw before, something times the second derivative plus, or a constant times the second derivative plus another constant times the first derivative plus a constant times y equals, and then on the right hand side we're going to have various different kinds of functions of x. The simplest is going to be the right hand side is just a constant. Then we could have the right hand side being a linear function of x. We could have it being a quadratic. We could have an exponential function, and we could have a combination of trig functions. So let's have a look at the first example here, and then we'll go on to a series of related examples. So here we've got something very similar to what we saw before, but on the right hand side we've got equals 3 instead of equals 0. So for each of these equations we're going to start by solving the homogeneous equivalent to this. So we're going to solve, let's just write it in a short form, y dash dashed minus y dashed minus 6y equals 0. First, we're going to do that by writing the auxiliary equation. So AE is m squared minus m minus 6 equals 0. That factorizes to m minus 3 times m plus 2 equals 0. So m is equal to 3 or minus 2. And that means that the general solution to my homogeneous equation is y equals a e to the 3x plus b e to the minus 2x. When we're solving non-homogeneous equations, this is called the complementary function. What we now do is we say that, well, the complementary function is the solution to this left-hand side equals 0. So if we can find another solution, a more specific solution to this equals 3, then our solution, that's called a particular integral, plus the complementary function will also be a solution to this equation, because this is a solution to this equals 0. So if we add them together, we're going to be adding on 0. We're still going to get a solution. Let's see how that works. So we're going to say that we're going to try. This is sometimes called a trial function. Y equals, because this is a constant over here, we're going to say y equals a constant here. So y equals lambda as our particular integral. So what we're now going to do is we're going to differentiate. So we're going to say y dashed differentiate is equal to 0, and y double dashed is equal to 0. We're going to take these three things and substitute them back into this equation. So we're going to say 0 minus 0 minus 6 times y, which is just lambda, so minus 6 lambda is equal to 3. And that gives me lambda is equal to minus a half. So lambda equals minus a half is my particular integral. Once we've found the particular integral for any differential equation, the general solution is going to be adding together these two things, complementary function and the particular integral. So general solution y equals the complementary function plus the particular integral. So in this case, that is y equals a e to the 3x plus b e to the minus 2x minus a half. We're adding on this minus a half. So that is my general solution now to my non-homogeneous differential equation that I started with. Let's go on to example B, which, as you can see, is very similar to example A. What we've got now is we've got 2x on the right-hand side. We're going to start in exactly the same way by solving the homogeneous equation. So we're going to get the same complementary function. So we're going to say same homogeneous equation as part A. So same complementary function y equals a e to the 3x plus b e to the minus 2x. Okay, we're not going to go through that again in this case. Now we're going to say that our the right-hand side of our equation is linear, so our particular integral is going to be linear as well. So particular integral, we're going to try y equals lambda plus mu x. We're going to differentiate twice, so y dashed is equal to mu, y double dashed is equal to 0. We're going to substitute into this equation, so we're going to say 0 minus mu minus 6 times lambda plus mu x is equal to 2x. And then we're going to compare coefficients of x, or any powers of x, so of x and of the constant terms here. So compare coefficients. So x, on the left hand side we've got nothing from here, we've got minus 6 mu is equal to 2, so mu is equal to negative a third, and then constant we've got minus mu minus 6 lambda equals 0, so minus 6 lambda equals mu, so lambda is mu divided by minus 6, so that's positive 1 over 18. So we've got our particular integral now, so we can say so pi is, what did we have, lambda, so that's y equals 1 over 18 plus, oh no, sorry, minus, that should be minus a third x. So the general solution is, again, we've got our complementary function plus our particular integral, so that's y equals a e to the 3x plus b e to the minus 2x minus a third x plus 1 over 18. And if you check by differentiating, you will find that that is a solution to the equation we started with. Let's have a look at example C now. Example C, we're going one step further. We've now got a quadratic on the right-hand side. And we've just got 3x squared. We would follow the same process if we had a full quadratic, so 3x squared minus 5x plus 7 or something of that nature. Again, we've got the same complementary function, same complementary function as A and B. I'm not going to write that out again. So this time we are going to make our particular integral a quadratic. So try y equals, let's have p x squared plus q x plus r as a particular integral. We need to differentiate, so y dashed is equal to 2p x plus q, y double dashed is equal to 2p. We're going to substitute back into our equation, so y double dashed, that's 2p minus y dashed, that's 2p x plus q, minus 6 times this, 6 px squared plus qx plus r has got to be equal to 3x squared. We're going to compare coefficients again. Compare x squared. Well, the x squared just comes from here, so we've got minus 6p is equal to 3, so p is equal to minus a half. X, what have we got for x? Well, we've got minus 2p here. We've got minus 6q there is equal to 0. We know what p is, so we've now got 6q is equal to minus 2p. Minus 2 times p is 1, so q is equal to 1 over 6. Oh, I got that right. Yep. And then we're going to compare the constant terms, which are 2p minus q minus 6r is equal to 0. So 6r is equal to 2p minus q, which is 2p, so it's minus 1 minus 1 over 6. So that's minus 7 over 6. So r is equal to minus 7 over 36. So just going back to our trial for the particular integral, we've now found these p, q, and r. So we can now say what the particular integral is. So pi is, what was p? Minus a half x squared plus 1 over 6 x minus 7 over 36. And the general solution is y equals a e to the 3x plus b e to the minus 2x minus a half x squared plus 1 over 6 x minus 7 over 36. Now, our right-hand side of our equation might not be powers of x. So the next example, again, looking very familiar. Same thing on the left-hand side, but this time we've got e to the x on the right-hand side. We could have e to the 5x or some other exponential function here. So again, we've got the same CF as A, B, and C. And we're going to make our right-hand side, our particular integral is going to be something times e to the x. If we had e to the 5x here, we'd make it something times e to the 5x. So we're going to have try p I y equals lambda e to the x. So our dy by dx is equal to lambda e to the x, and our d2y by dx squared is also equal to lambda e to the x. So substituting back in here, we've got lambda e to the x minus lambda e to the x minus 6 lambda e to the x is equal to e to the x. These two cancel each other out, so we've got minus 6 lambda equals 1, so lambda equals minus a sixth. So our complementary function, our particular integral is y equals minus a sixth e to the x, and our so CF is y equals minus a sixth e to the x. General solution is y equals a e to the 3x plus b e to the minus 2x minus 1 over 6 e to the x. So you can see that we've actually got a combination of three exponential functions here, one of which we know the coefficient for, but the other two we don't know the coefficient, and we would need values to substitute in order to find those. The final example we're going to go through here, again related, has a trig function on the right hand side. Again, same CF as A to D. Try on the right hand side now. If we've got a trig function here, then what we're going to do is going to try a combination of sine and cosine, but it's of the same thing here. So it's sine of 3x and cos of 3x. So we're going to say try y equals p cos of 3x plus q sine 3x as our particular integral. So then dy by dx is equal to minus 3p sine 3x plus 3q cos of 3x d2y by dx squared is equal to minus 9p cos of 3x plus 9q sine of 3x. And it's just worth noting that this is sometimes quite useful, that this is equal to, oh sorry, that should have been a minus sign there, shouldn't it? There we are, minus 9q sine of 3x. That this is equal to minus 9 times y. So minus 9 times what we had here. Okay, so now we need to find what p and q are by substituting into here. So if we do that, we're going to get minus 9p cos of 3x minus 9q sine of 3x, that's the d2y by dx squared, minus this dy by dx, so that's plus 3p sine 3x minus 3q cos of 3x, and then minus 6 times this, so minus 6p cos of 3x minus 6q sine of 3x, and that's all equal to 72 sine 3x. We're going to compare coefficients for sine x and cos x, sine of 3x and cos of 3x. So compare sine of 3x. Well, what have we got? We've got minus 9q here. We've got plus 3p minus 6q is equal to 72. So that works out to 3p minus 15q equals 72. If we compare cosine cos of 3x, we get minus 9p sine minus 3q minus 6p is equal to 0. So that is minus 15p minus 3q equals 0. And we now have to solve those two simultaneous equations. I'm going to turn this one into 5p plus q equals 0, and this one into p minus 5q equals 24. Then if we multiply the top one by 5 and we add, we're going to get 26p, aren't we? Wait a minute, we'll go to the top and add, yeah. Okay. 26p is equal to 120, so p is equal to 26 over 120, that doesn't know, sorry, 120 over 26, which is, oh, I got that right, I don't think I have, p minus 5q No, equals 24 I should have here. That's what I've done wrong. So P is equal to 24 over 26, which is 12 over 13. Good, that's what I was expecting. And that gives me Q is equal to minus 5P, which is minus 60 over 13. Oops, I've got it so you can't see it. So we found our particular integral. So Pi is, let's go back to it, y equals 12 over 13 cos of 3x minus 60 over 13 sine of 3x. And that means that our general solution is y equals a e to the 3x again plus b e to the minus 2x plus 12 over 13 cos of 3x minus 60 over 13 sine 3x. Now, I would suggest that what you do is pause the video here and do question 1 and question 2 in exercise 7C in the Corpure book 2 textbook. That's on page 161. I'm going to go straight on to